Grounding metal veneer involves specific methods outlined in the National Electrical Code, specifically Section 250.116F. This section permits the use of copper-clad steel rods or pipes as electrodes for grounding metal veneers. A typical installation might involve 3/4-inch diameter copper-clad steel rods that are 10 feet long and spaced at a maximum of 100 feet apart, connected to number 1/0 copper wire. Regarding the bonding method, each individual metal panel should be bonded to the grounding system using a bonding jumper. These jumpers are typically made of copper or aluminum and should be sized appropriately for the specific application. For overlapping panels, a jumper should be installed at each overlap to ensure continuous electrical connection. For corner moldings, jumpers should be installed at each corner where metal panels meet to maintain the electrical continuity of the grounded system. When dealing with trim and flashing, jumpers should be installed at any location where trim or flashing is fastened to metal panels to ensure these components are also effectively grounded. When installing, it's important to consider several factors. Firstly, bonding jumpers should be installed before the metal panels are fully secured in place. Secondly, bonding jumpers should be installed in accordance with the manufacturer's instructions to guarantee proper functionality. Thirdly, it is crucial to ensure that all bonding connections are secure and make good electrical contact to provide a reliable path to ground. All ground rods used for the metal veneer must be bonded to the grounding electrode system for the service. This can be achieved using a grounding busbar or another approved method that ensures a low impedance connection to the main grounding system. It is important to consider that the grounding method and bonding requirements for metal veneers may vary depending on local codes and regulations. Therefore, it's always advisable to consult with a local electrical inspector for specific guidance and to ensure compliance with all applicable codes. Metal veneers should be grounded to protect against electrical hazards such as shock, fire, and lightning strikes. A properly grounded metal veneer provides a path for fault current to return to the source, allowing overcurrent protective devices to operate and clear the fault. It also helps to equalize potential differences, reducing the risk of electric shock. The size of the bonding jumpers is critical for safely carrying fault current. The NEC provides tables that specify the minimum size of the bonding jumper based on the size of the overcurrent protective device in the circuit. Using an undersized bonding jumper can result in it overheating and potentially causing a fire during a fault condition. It is also important to ensure that the bonding jumpers are properly installed and protected from physical damage. The connections should be made using approved connectors and methods to ensure a reliable and long-lasting connection. The grounding electrode system typically consists of one or more grounding electrodes that are connected to the building's electrical system. Common types of grounding electrodes include ground rods, metal water pipes, and concrete-encased electrodes, also known as UFA grounds. The grounding electrode system provides a low impedance path to ground for fault current, helping to protect people and equipment from electrical hazards. The connection between the metal veneer grounding system and the building's grounding electrode system is critical. This connection should be made using a properly sized grounding electrode conductor, and it should be installed in a manner that minimizes impedance. The grounding electrode conductor should be connected to a grounding busbar or other approved termination point within the building's electrical system. Proper grounding and bonding of metal veneer are essential for electrical safety. It is important to follow the requirements of the NEC and local codes to ensure that the installation is safe and effective. Consulting with a qualified electrical contractor or inspector can help to ensure that the installation is done correctly. When dealing with different types of metal veneers, such as aluminum or steel, it is important to consider the compatibility of the bonding materials. Dissimilar metals can corrode over time, which can compromise the integrity of the grounding and bonding system. Using compatible materials and proper installation techniques can help to prevent corrosion and ensure a long-lasting and reliable connection. In addition to the specific requirements for grounding and bonding metal veneer, it is also important to follow general electrical safety practices. Always to energize circuits before working on them, and use appropriate personal protective equipment such as gloves and eye protection. If you are not comfortable working with electricity, it is best to hire a qualified electrical contractor to do the work. Regular inspections of the grounding and bonding system are also important to ensure that it remains in good condition. Look for signs of corrosion, loose connections, or physical damage. If any problems are found, they should be corrected immediately to maintain the effectiveness of the grounding and bonding system. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. Changes to the code can affect the way that metal veneer is grounded and bonded, so it is important to be aware of these changes. There are many resources available to help you learn more about grounding and bonding, including online courses, training programs, and publications from organizations such as the National Fire Protection Association (NFPA) and the International Association of Electrical Inspectors (IE). Understanding the principles of grounding and bonding is essential for anyone who works with electricity. By following the requirements of the NEC and local codes, and by using proper installation techniques, you can help to ensure that electrical systems are safe and effective. Always remember that electrical work can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. If you have any questions or concerns about grounding and bonding, it is always best to consult with a qualified electrical contractor or inspector. They can provide guidance and ensure that the installation is done correctly and safely. Firstly, the grounding and bonding of metal veneer should be performed by qualified personnel who are familiar with NEC and local codes. Secondly, all materials used for grounding and bonding should be listed and labeled for the intended use. Thirdly, the grounding and bonding system should be inspected and tested after installation to verify that it is functioning properly. Fourthly, a record of the grounding and bonding system should be maintained, including details of the materials used, the installation methods, and the test results. Fifthly, any modifications or repairs to the grounding and bonding system should be documented and performed by qualified personnel. Sixthly, the grounding and bonding system should be periodically inspected and tested to ensure that it continues to meet the requirements of the NEC and local codes. Seventhly, any deficiencies identified during inspections or testing should be corrected promptly. Eighthly, all personnel who work on or near the grounding and bonding system should be trained on the proper procedures for safe work practices. Ninthly, the grounding and bonding system should be protected from physical damage and environmental factors that could compromise its integrity. Tenthly, the grounding and bonding system should be designed and installed in a manner that minimizes the risk of electrical shock and fire. In addition to the technical aspects of grounding and bonding metal veneer, it is also important to consider the aesthetic aspects. The grounding and bonding system should be installed in a manner that is visually appealing and does not detract from the overall appearance of the building. This can be achieved by using concealed conductors and connectors, and by carefully planning the layout of the grounding and bonding system. In some cases, it may be necessary to use special grounding and bonding techniques to accommodate the unique features of the building or the metal veneer. For example, if the metal veneer is installed on a building with a complex geometry, it may be necessary to use multiple ground rods and bonding jumpers to ensure that all parts of the metal veneer are properly grounded and bonded. Similarly, if the metal veneer is installed in a corrosive environment, it may be necessary to use special corrosion-resistant materials for the grounding and bonding system. The grounding and bonding of metal veneer is an important aspect of electrical safety, and it is essential to follow the requirements of the NEC and local codes to ensure that the installation is safe and effective. By understanding the principles of grounding and bonding, and by using proper installation techniques, you can help to protect people and equipment from electrical hazards. Remember to always consult with a qualified electrical contractor or inspector if you have any questions or concerns about grounding and bonding. It can provide guidance and ensure that the installation is done correctly and safely. The primary purpose of grounding is to limit voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines and to stabilize the voltage to earth during normal operation. Bonding, on the other hand, ensures electrical continuity and conductivity of metal parts that are likely to become energized, creating a low impedance path for fault current to facilitate the operation of overcurrent protection devices. A grounding electrode system connects to the earth and provides a reference point for the electrical system's voltage. Common grounding electrodes include metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. The grounding electrode conductor connects the grounding electrode to the equipment grounding bus or terminal in the service equipment. Equipment grounding conductors connect non-current carrying metal parts of equipment to the grounding system, ensuring a low impedance path for fault current. Bonding jumpers connect metal parts to maintain electrical continuity and conductivity, reducing the impedance of the grounding path. The size of grounding and bonding conductors is determined by the size of the overcurrent protection device in the circuit. Using conductors that are too small can result in inadequate protection and increased risk of electrical hazards. The National Electrical Code provides tables specifying the minimum size of grounding and bonding conductors based on the rating of the overcurrent device. Proper installation of grounding and bonding conductors is essential for their effectiveness. Connections should be made using listed connectors and fittings, and conductors should be protected from physical damage. Grounding and bonding connections should be accessible for inspection and maintenance. Regular inspections of grounding and bonding systems can help identify potential problems before they become serious hazards. Look for signs of corrosion, loose connections, or damaged conductors. Any issues should be addressed promptly by a qualified electrician. In addition to complying with the National Electrical Code, it is also important to follow any local codes and regulations that may apply to grounding and bonding. Local codes may have additional requirements or more stringent standards than the NEC. Consulting with local electrical inspectors can help ensure compliance with all applicable codes and regulations. Grounding and bonding are not the same thing, although they are often used together. Grounding provides a path for fault current to return to the source, while bonding ensures electrical continuity and conductivity. Both grounding and bonding are essential for electrical safety. Improper grounding and bonding can create serious electrical hazards, including electric shock, fire, and equipment damage. It is important to take grounding and bonding seriously and to follow all applicable codes and regulations. Working with electricity can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. Always de-energize circuits before working on them and use appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. The use of copper-clad steel ground rods offers a balance of conductivity and mechanical strength, with the copper providing a good conductive path and the steel providing the necessary structural support to drive the rod into the earth. The depth to which a ground rod must be driven depends on soil conditions and local code requirements, but a common minimum depth is 8 feet. The resistance to ground of a grounding electrode system should be as low as possible, ideally 25 ohms or less. A lower resistance to ground provides a better path for fault current and reduces the risk of electrical shock. Ground resistance testing can be performed using specialized equipment to verify the effectiveness of the grounding electrode system. Soil conditions can significantly affect the resistance to ground. Sandy soils tend to have higher resistance than clay soils. Soil moisture also affects resistance, with wetter soils having lower resistance. It may be necessary to use multiple ground rods or other methods to achieve the desired resistance to ground in areas with poor soil conditions. The connection between the grounding electrode conductor and the ground rod should be made using a listed connector suitable for direct burial. The connector should be installed in accordance with the manufacturer's instructions to ensure a reliable and corrosion-resistant connection. The grounding electrode conductor should be protected from physical damage where it is exposed. This can be accomplished by running the conductor in conduit or by using other protective measures. The location of the grounding electrode system should be accessible for inspection and maintenance. The area around the ground rods should be kept clear of obstructions to allow for easy access. Regular inspections of the grounding electrode system can help identify potential problems before they become serious hazards.